Recording in progress.
Okay, I think hopefully that'll work. Yeah, someone say something, please.
Hello.
Yes, okay, thank you, Erica. Okay, it's working. You know, I had to reboot my Mac. I haven't done that in like maybe a year or something. So so that's great. What happened? Something really weird. Okay. Anyway, so I'm glad to see you guys here. Week 6, and this is the week of the midterm. So you guys are probably, hopefully, you know, brushing up on the material in LOSAF LOSAF's modules. Yeah. Okay. That's what the tests will be based on. Exams and tests will be based on. Now, but I was looking to see that, you know, we were working on something last class, you know, the code that Karthik posted. And then nobody took that up except Hannah, who posted something this morning, and I saw it. It's really good. Well, I haven't tried it yet. I haven't tried it yet because I mean, you just posted it. But we can try it in class. Okay, we can try it in class. And in fact, what we can do is we can take Hannah's code and try and make some. I know she mentioned something in the Reddit. You said you haven't tried something. Docking points for you know, yeah, we can try that today in class. But I think it looks kind of cool so far from what I've, you know, I did a quick look on my iPad. I haven't played it, so we can do that today. If you have any other questions, anything else about the midterm, you should just feel free to ask. We can start. What time is it now? Yeah, we can start about 4 minutes. Okay, we'll start at 8:15. If you have any questions for me, you can ask. If you have any questions for your classmates too, this is the time to basically chat amongst yourselves and say, you know, hey, is there something that we can focus on today? Can we ask Anand to go over this concept? Anything is okay, right? So the only things I won't, so if you ask me to talk about, let's say, pointers, maybe I won't do that today because it's not in your midterm and it's not going to help you for your midterm. So we'll keep that until the second half of the course. But everything else, anything we've covered so far, feel free to ask, okay? Even the projects that you're working on, all fair game. Yeah? Okay, all right. So nobody has any questions at all? All right, nobody has any suggestions as to what we want to do today? Otherwise, what we'll do is we'll just pick up Hannah's code and try and review it because I haven't looked at it in detail. It looks okay from on my iPad, so we can take a look at Hannah's code and then we can try and make the changes to it that Hannah put in the comments. Oh, I know, was in the comments or in the post saying, hey, this is something that I wanted to do. We can try and do that today. Okay. Yeah. And hopefully more of you can pick up that code from today, right? So the code that Hannah wrote, and then we develop more in class today. You can pick that up and say, hey, I added some more bells and whistles to it, right? And then you can share your own versions of the moving star game, you know. Oh, I don't know, is that what you called it, Hannah? Moving star game? Okay, moving star game. Okay, so we can do that. Anyway, who wants to code today? Who wants to code today? I think looking at the screen, the only people who haven't coded so far, I believe, are Yu Yang and Sabrina. Yeah, everybody else has had a chance to code on screen today. I mean, on screen, not today. So far, book me for this Thursday. Okay, all right. Yu Yang wants to go on Thursday, which pretty much leaves only Sabrina, and she's smiling, which means that she's okay with coding today. Yes, Sabrina, you're okay with coding?
Yeah, let me just join in on my computer so I can share my screen.
No hurry. So feel free to join. And then after you join, in a private window, go to Reddit and click on Hannah's link, and then we'll pick up Hannah's code. And we'll briefly review it because I've forgotten the exact details of what we tried to do last class. So that'll refresh our memory. And then we can go from there. And while Sabrina's getting ready, you guys should just feel free to ask me questions and talk, okay? You know, you guys want to talk amongst yourself, that's fine too. But keep the airwaves occupied. Say something or ask something.
What do I? Oh, there we go. me just.
Excellent, excellent.
Oh, this looks messy. Okay.
You can also full screen. Yeah, I think, yeah, you can. Once you full screen, it'll just cover your desktop and then we'll only look at this. Okay, so I think
Okay.
Hannah she has a link somewhere in that post to that online GDB place.
Is it this one?
Yeah, I think, no, I think there is a link. Yeah, at the bottom. Excellent. All right, let's and you can dismiss the blue panel, and we'll take a quick look at the screen, at the code. Let's go to main first, and let's look at what main does, and then we can work our way backwards through the code, top down to see what it actually does. All right, this is main, okay. All right, so we get the names of the players. Okay, that's good. Now, as I'm reading the code and I'm trying to understand what it does myself, you guys should also be trying to do the same thing. And if you don't understand something, you can also ask, okay? Because chances are most of us, or many of us might have forgotten, because we're doing all these other things. You have all these other classes, and you probably have midterms too. You have many more midterms this week, yeah? It's not just us, yes? Yeah, okay. So, chances are very high that you may have forgotten what the code does. So let's review it together. Okay. All right. Exactly the same as previously. Oh, I see. We want the track length to have an odd length. Okay. Yeah. Okay. All right. So we just say we have an odd length there. Okay. All right. Can you scroll down a bit more, Sabrina? All right. Place a star at the middle. Okay. All right, yeah, that's okay, that's good. And then player one, we're going to get speed. Okay, we'll do that separately later. Okay, and then temporary code to verify. Oh yeah, that's okay. So further down, and then we show the race happening. I see. We just say here are the player one, player two, and then we just show the race happening. Okay, so I see. Show race happening doesn't know the names of the players. It just has the two player speeds because it's just using the less than and greater than signs. Okay. All right, good. Now let's take a look at show race happening, because I think that is one of the core methods. Let's take it's further up. It's above main. I think there is a method called show race happening. Okay. All right. Okay. See how player one speed, player two speed. Okay. All right. So let's comment out line 73, because I think we put it in there to debug. So we can comment it out, line 73.
Yeah, sorry, I put it in there to debug. Sorry.
Oh, that's okay. That's the right thing to do. I think, I would have done that too. So that's why I thought I did it, or we did it in class. Okay. So it can comment it out now. Assuming that Hannah's already verified that it's coming in and the parameters are coming in. Okay. Yes. You verified the cout is doing the right thing there.
Is there a reason why it's not clicking? Like,
oh yeah, you have to fork. You have to fork the code.
Oh.
Because right now that code belongs to Hannah. Now this code belongs to you.
It was line 73. Okay.
Yeah. Okay. All right. If the track length is 0, all right, no race, we can return right there. Now we place this guy on the left side, and on the right side we place that guy, and then all right, we set the positions. Star position is in the middle. Okay, good. Yeah, further down. So it has a condition called win condition. Okay, false. Right, string win equals. All right, string win. All right. I don't know what string win is, but we'll come to that later. Okay. All right. Condition is false. Okay. Clear the screen and then get the speeds. Okay. Oh, hang on. Can you go up? Can you go up a little bit? For a little bit more. Oh, you're not getting the speed. Okay. It's just player speed, and the player speed changes. Does it? Does the player speed change every? Oh, it doesn't change. Okay. All right. Let's do one more minor cosmetic change here. Cut those two lines, 90 and 91. Cut those two lines and put them outside the while loop, right? And the reason I'm doing that is because it is loop invariant, isn't it? It doesn't change inside the value of the loop. Yes or no? Does the player speed change inside the value of the loop? No, right? Only the positions change. The speed doesn't change. Yes or no? Yeah, actually, I can hear you guys. Well, actually, I did hear Sabrina. Maybe I can hear Erica. I saw her lips move, but I didn't hear you. Can you say something, Erica?
It's okay. I was muted, but I agreed.
Oh, all right, okay, great. Well, when you're muted, I don't know if it's my, well, actually, I could hear Sabrina, so all right, good. All right, so
You said outside the while loop,
outside the while loop, yeah, not below, above,
but isn't that inside
above the while
loop?
loop, on top of the while loop, on top of the while loop.
Oh.
Yeah, and also what we'll do is, yeah, put a blank line. Yeah, there you go. Thank you. One more. Yeah, thank you, Sabrina. Okay, fantastic. You're doing things even before I think of them. That is great. Okay, so all right, different paragraphs. That's why it looks much nicer and cleaner now. Okay, so in clear speed. So the reason I moved them out of the loop, and again, these things are not so important in CS2A. Okay, but as you go on to professional level programming, these things are going to be so important. They become second nature to you. Okay, and the reason is, if you're a professional out there and you have an assignment statement inside a loop, and then the left side of the assignment is not changed in the loop, a colleague that walks in might give you a tip saying, hey, you know what, why are you assigning repeatedly in the loop when it's the same value? If it's the same value, you might as well assign it once outside the loop. Why waste cycles? Machine cycles are being wasted by assigning the same thing over and over again. Yeah, so that is the reason why we move things outside. These are things that you'll pick up by experience anyway. So it doesn't matter that you're doing it this way. And even if you don't remember this and keep doing it this way again and again, by the time you're in 2B and 2C, you'd automatically have figured out. Even if nobody tells you, you would automatically have figured out. Okay, hey, what am I doing? Putting that loop, thing in there. You should move it out, and you'll do it yourself. So I'm just doing it for you now. Okay, so you're clearing the screen. Okay, and get the. All right, now.
Wait, sorry. Oh, why are we putting it out? Don't we need to like constantly update it? Because like there's that sleep time.
No, but yeah. So the speed is not updated. Is the speed being updated?
No, I'm updating the position.
Oh, I'm so sorry, Hannah. Yes, thank you for, I'm so sorry. You can do Control Z and put it, no, you can't do Control Z because you'll lose the blank lines and all, right? Yeah, you can put it back. I thought she was updating the speed, right? I wasn't looking at the whole statement, my fault, okay? So, all right,
Wait,
good.
also, could you like move the if statement? Is that supposed to be the win condition? Can you move it to the end? I don't know why I put it in the middle of the while loop.
I'm sorry, the if statement, what is about the if statement?
The if statement is supposed to like check if it's like if there's like a win or not, but like I put it in like I put it in the middle of the while loop for some reason. So
oh, I see. Yeah. All right. So you can take the two player one pause, the two assignments that you have, and move them below the if statement. I think that's what Hannah is saying, right? Triple click on the line and then drag one more down. Drag while triple clicking. Don't let go of your finger and drag down. No. While no. Control Z. There's Command Z or Control Z for you, right? Triple click, don't let go, and then drag, right? These are things that you, no. Triple click, don't pull up your index finger, and then drag while you've got it pressed down. Yeah, there you go. Right, that way you can select multiple lines. Now you can Control X. Right, one more backspace, one more backspace, one more. All right, now go to the place below the if statement, below the if statement. Below the if statement. That entire thing is the if statement, right? No, that needs to be there. Yeah, so below the if statement. Yeah, there you go. Hit enter, right? And paste. Triple click and paste. All right. That's right. If you triple clicked and paste, you wouldn't have had to do that, but that's okay. All right. Now, while we're doing this, let's tidy up just a little bit. Let's insert some spaces after on both sides of the else statement, on both sides of the else keyword. So it's slightly cleaner. For me, it doesn't actually matter that much. Many people may think that it's okay. No, that's okay. All right. So you do get the positions. Right, if the position is what's D1 and D2. All right, so D1 and D2. What are D1 and D2?
So like I
temporary positions. Temporary positions.
No, I was thinking because when you do the speed's going to be calculated really close to each other, so it might be like really like there might be really a close call. So it's just like the position minus the start position, like. I see.
Hang on. All right. So, hey, Sabrina, can you move your mouse just a little bit? It's over the equal sign. I can't see what it is. Okay, it is equals, not plus equals or anything. So into D1 equals, you're getting the player one position minus the star position. And then, so basically it's how much, how much they have covered. Yes. What the distance they have covered is what you're measuring, isn't it, Hannah?
Yeah, like if we already know that one of them has won, like what one is like it's supposed to be in the case where both of them are across the winning line.
Oh, it is for the case. It is, I see. It is for the case where they have crossed over. That you're trying to, that is what you're trying to calculate there. Yes. I see. Okay. All right. So I was thinking of the other situation, the first situation where, you know, have they met the place? But, you know, Hannah has thought about the case where they've come close to the star, but they didn't actually hit the star, but they moved over the star and gone on to that side and this side. So they don't actually meet at the star. They've crossed over. So we'll handle that situation separately. Okay. Yeah. But thank you, Hannah. Right. So D1, D2, D1. I see. So, all right. Now you take the positions. All right. So, here's what we can do. Okay, we'll make something really. We're going to just condense the code a bit. It's essentially what Hannah wrote. I'm just going to condense it a little bit so that it's easier. Less code. All right, less code lines. Right. So here's what we'll do. Will we say? Right here, let's make this win variable an int variable for now, right? So actually, you know what? No, wait. Oh, I see. Let's leave it like how Hannah has. Okay, for now, that's okay. Okay. All right. So can you scroll down a bit more? So 107, 108. You can get rid of some blank lines under that. One more. Right. Set pixel add position. Yeah. Okay. Oh, I see. Oh, yeah. Track. Let's say I see Hannah's using the numbers 1 and 2. I think, right, I might be mistaken. I think that if the left runner is a greater than sign and the right runner is the less than sign, it may look nicer than the numbers 1 and 2 coming to each other. I don't know. I might be wrong, but let's try with 1 and 2. Okay. All right. So 1 and 2. Yeah, I think that looks okay. Is there anything else we need to verify in this code before we run it? Maybe let's look at the get player speed. Okay, there's one more thing. Get player speed. All right, so start now. I see. Okay, all right, good. All right, now so this is the place where we'll make some changes later. The rest of the code, as Hannah has written, is pretty good, right? Actually, we'll make one cosmetic change though. All right, so go to the main method. Where Hannah has this variable called win. Okay, no, in main, is it main? So there's a message called win. Where is this variable called win? She has a variable called win. I see. Show race happening, and the challenge is that here is that show race happening is also communicating to the user with a string saying, oh, winning message. So ideally, I'm just thinking aloud. Okay, so here's the thing. I'm thinking aloud rather than making my decision in my head and saying this is what we should do, which means that I could potentially be wrong. I could be going down the wrong track, but eventually, right? All of these are opportunities for you to step in and correct me, right? And say, hey, you know, maybe that's not the way to think about it. And so these are all great. And you may get extra credit for it too, right? If I'm thinking about something completely wrong and you say, that's not the way to do it, you may get extra credit for it. So these are things that you should actually jump at. Okay, so here's what I'm thinking. Ideally, I'm thinking this show race happening should show the race and basically just return a value. It shouldn't say who won and so on and so forth, because its function is just to show, not to say anything. So I think what we can do here is make it so a show race happening. What does it return? What does show race happening return? The declaration. Go to the declaration part. No, above. No, furthermore. I see, it's void. How about we make it return an int? Okay, we make it return an int, and insert a comment on line 71. Hit enter on line 71. Yeah. We'll put a comment there that says this function will return a 0 if no, it'll return negative. It'll return a negative number if player 0, 1 or player 1, 1. A positive number if the other player 1, right? Player 2, 1. Positive number if the other player 1. No. This function will return a negative number if player 1, 1, right? If the first player 1. Let's say if the first player 1, 1, right? And a negative number. Yeah, positive number if the other player 1, and on the next line you want to say and 0 if there was a tie. Okay, so that way we can this method can be insulated from talking to the user. Does it make sense? Okay, because when we code, we want to make very clear in our heads. There are a bunch of methods that can talk to the user. There are these bunch of methods that are workhorses. They do stuff in the background, but they're not going to talk to the user. Yeah, so we make this distinction, and that makes for better programs. You'll find out by experience, it makes for better programs. Just like you're, opening a shop, for example, right? A car servicing shop, right? You have people that are front desk, receptionist, all these people out there, but they don't talk to they talk to the user and say, well, the customer comes in and they talk to them, but they're not going to go and say, well, let me go and take a look at your car, open it up and say, hey, you need to replace that valve, right? They don't do that. That is done by the mechanic. However, the mechanic can't come and say to the, hey, you know what, get the, front desk guy out of the place. I'm going to tell you what's right. So you get this clear thing. That way you can focus on one thing and get it right and do really well in the job that has been assigned. So that's what we're going to do here. So here, what we'll do is let's go to do in a loop, right? So can you scroll down just a little bit? Scroll down just a little bit. Here we'll say yeah, on line 88, hit enter on line 88. We're going to keep Hannah's code there, but comment it out for now. Okay, so comment out line 88. No, comment out line 88, and we'll say int result equals 0. Okay, so result equals, and put a comment there on that line saying we'll start off no winners. Well, let's say assume no winners. We'll say assume no winners at the beginning, right? Assume no winners at the beginning. Okay, great. Okay, now we're going to go through that loop. Okay, now where you say and further down where Hannah says win equals congrats player 1. Okay, if D1 is greater than D2, I see, that is okay. If D1 is greater than D2, we just return that value. So what we can do here is, okay, here's what we'll do, right? So we're going to condense all of that. So go to line number 97, go to line 97, hit enter, and say, if D1 greater than D2, you can just say return D1 minus D2. Yeah, I think that should work. Okay, and you don't need braces even, right? You don't need braces. You can just, it's just one line. Now you can comment out lines 100 to all that entire if statement 100 to 109. You can comment out. Oh, that's a pain if you have to do it manually like that. No, actually just comment. Okay, select that block. So yeah, that's better. Yeah, put a block comment. And you can also get rid of that blank line. You have that blank line in the else, inside that else you have a blank line, or in the previous one too, right? So all right, so now it would just return right there. Otherwise it'll update the player positions and then update the screen, and then so further down. Excellent. Let's do one change here. Wait, I think we have a clear somewhere. Yes, clear up, further up. Yeah. Now triple click on the line and cut it out. Triple click on that line, cut it out. And by the way, why is the if statement lined up with the while? It should be there. maybe I messed up the indentation. It should be indented in. It's part of the while statement, so it should be there.
Wait,
Maybe it
shouldn't
was
we
there because
oh, sorry.
Hmm?
Shouldn't we put the if statement for the when condition at the bottom of the while loop? So like once we update all the movements, then we
yes,
check for the
yes,
when
yes.
condition?
Very good point. Very good point. Okay. So yeah, let's do what Hannah's suggesting. Just no, not there. Just to triple click on 93, drag down to 94, get that also. Oh no, triple click on 93. Well, actually, what I was going to do was move the clear below. Right, just triple click on line 93. Let's do what Hannah's saying. Okay, and then copy that thing. Copy that. Copy the entire if statement. Copy that entire if statement. I think that's what Hannah is saying. Copy that entire from 92.
Okay.
Click and drag all the way to 107. 92.
Okay,
Click on
hang
drag.
on. Let me paste that there so I don't lose it.
Yeah. Okay. Yeah, we can
Um,
put it back later.
Wait, 93 to 107?
108. 93 to 108. In fact, you know what? We can actually, that block comment you have with Hannah's code, you can delete that because it's all been preserved anyway. You can get that code back by just going to that online. You can get rid of the comment. Get rid of that block. Get rid of lines 100 all the way to 108. Yeah, get rid of it.
Like
Delete.
delete?
Yeah, and then all right. So if when condition equals true, all right. So D1, D2, play one, just be okay. All right. So what Hannah is saying is now you can cut line 93 from line 93 onwards. Yeah, all the way to the
Until-
bottom of the if statement. No, is it to the bottom? No, wait. Oh, gee, hang on. Something is missing here. Okay, wait a sec. Maybe I'm not reading correctly. All right. So I want to. Is it possible to? Can you dismiss the lower part, the console, also, so I can see more of the code? Yeah. All right. So great. Okay. So we cleared the screen, and then when condition true, D1. Oh, I see.
Is there a
We'll
curly
do.
bracket?
Can we do a bit of refactoring, Hannah, if you don't mind? Well, or if you want to do it too, that is fine. So if you want to do some refactoring, that is fine. It's your code looks good. I just want to do a little bit of refactoring so that it looks differently. But essentially, it is exactly the same logic. Most of your programming style will also be maintained. We're just going to reduce the number of lines of code. Try to reduce the lines of code. Is that okay with you?
Yeah, I just think there's a curly bracket missing.
Yeah, that's what
Because-
it seems like to me. Hey, Hannah, what's going on? Not Hannah. Yeah. All right, great.
Sorry.
Yeah. Okay. Right.
Okay.
So yeah, there is it seems to me like there's a curly bracket missing, right? So something got lost in the cut and paste when we were fiddling with Hannah's code. So let's not worry about it now. We'll just fix it all up as we'll just do it. Okay. So now scroll up a little bit so we can see more of the code now. So I can see more. Thank you. Right. So all right, great. No, that's enough. Okay. So here's what. All right. So
I think
we
I
have.
found the curly brace. It was supposed to be after the if D1 is greater than D2, return D1 minus D2. There's supposed to be a curly brace between that and player one underscore P position.
Oh, is that right? On line 100. You're saying on line 100?
Yes.
Yeah, that's what I thought. Okay. Yeah. Can you put the curly brace there on line 100? Close it. Right now, indent the entire if statement in by 4. Actually, click, drag, select, and then hit the tab key. It'll automatically indent. I think Mohammed or someone tried it and it worked. Triple click, drag down to line 100. Triple click, drag down to line 100. Now hit the tab key after that. Hit the tab key. Yay! Okay, it did work. I don't know. Maybe it was Mohammed. Someone did that and it worked. Okay, so all right. So clear the screen. Now cut that clear 1D screen. Cut the line 91. Triple click and cut line 91. Right now, put it there. Put it on line. Go to line 107. 107. Yeah, and now hit enter. Hit enter. Enter, and now paste. And get rid of the blank line after that. And the reason I'm doing that is because even though the part that we moved over is very small, happens in milliseconds, maybe, right? Nanoseconds even, very quick, very quick. Even then, we don't want a flicker to happen, okay? Because assume that it was not a few milliseconds. Assume that because of your computer being loaded or the server being loaded, that even though it was simple calculations in there, it took like half a second, okay? Half a second. That means a clear and then a half a second gap, and then the screen is drawn, okay? That introduces an unsightly flicker on screen in animation. So what we say is that let's try and keep the blank screen to a minimal, minimum effect. So we say, if you have to do any calculation, don't do it when the screen is clear. Do the calculation, then clear the screen, and then redraw it. So there's minimal time between the clear and the redraw, so the flicker effect will be minimized. That's what we were trying to do there today. Okay. Otherwise, other than that, I think the logic was okay. So all right. So when condition equals false. Yeah, okay, set pixel at clear screen and then print 1D screen, okay, and then we sleep for 1 second, and inside the loop, say only if they're crossed over. That is the only win condition, right? The only win condition we have is when they're equal to is also good, right? So that is great. So in fact, what we can do is oh, I see. If it enters, it's going to return. So that'll actually automatically break out of the loop too. So we are good. We're good. So win condition equals true. So why do we have this win condition equals true there? We don't need that variable, right? So in fact, what we can do is, because we know, right? So here, this is something that what's the best way to say this? Maybe it'll just come by practice. Okay, it'll come with practice. Now we're going to say make the while loop an infinite loop. Okay, so instead of win condition equals false, just say while true. While true. While true. Get rid of the entire condition. Yeah. Instead of that, just say true. No, within parentheses, and then have the same thing, that the curly brace after that and all. Yeah, there you go. Right, and put a curly brace after that, space curly brace. Right now, and then get rid of that Boolean win condition equals false. Right, get rid of that. Get rid of the two lines 87 and 88. Triple click on 87 and 88. Return, delete them. Okay, all right. And then and also get rid of 86, because I think we started to do a comment there and then we left it incomplete, so it doesn't matter. Right, result equals 0. Right, while true, we're in here, and if it's here, it's gonna. Is this main or a show? By the way, is this show or main? It is show. It is show, because it's returning that thing. Okay, so it's and then we don't need that win condition equals true. Right, get rid of the line 90. Get rid of line 90. Yeah. All right. Now, in fact, you can actually do. Oh, this is good. This is good. But I was thinking we don't need two separate variables. We can D1 and D2, but it's good. It's good to have it like this because it's more readable. All right. Now, player one's pass, player speed. All right. And then why? Oh, I see. We just add the speeds and then subtract. Set pixel add. All right. So I think that is oh yeah, we have to go to main and then get rid of line 109. We're not going to do any prints here. All right, we're not going to do any prints, and then we get rid of all those 109, all the comments we wrote right below that. Get rid of all of that. Now we need to do one more thing, I think, because it returns an integer, right? So what we need to do, oh, if it returns, if it's in that loop, if it gets in that, it's gonna, right? Yeah, I was about to say that and I forgot. Okay, right. So whenever you make an infinite loop in your program, like for semicolon or while true and things like that, you have to be like super duper careful that it's not truly infinite, that there is a condition in there that is certain, 100% certain, right? Not most likely, right? Most likely never works, right? A long time ago, I was having a dinner, with a friend in a restaurant, and that restaurant had a magician, right? They have different entertainers come by. So there was a magician on the day that we were eating, and the magician would go and do magic tricks. When the patrons are sitting and eating, he'll just come and do some magic tricks. And so so my friend and I were eating, his magician came over, and this is an incredible trick. And then we couldn't figure it out. And then he did the same trick to my friend too. And then my friend also couldn't figure out how it happened. Then I said, I think I know how it works. It works 99% of the time, according to this statistical model that I have in my head. So is that how you're doing it? And he said, the magician said to me, right? Real magicians never do tricks with only a 99% chance of success. Real magicians will never do a trick unless it has a 100% chance of success. This is incredible, isn't it? Right? So that's, and he says, just because I'm going to get most of the people in the audience, it doesn't work for me, right? I have to get every single person, right? Even the doorman standing by there, that everybody needs to be impressed. And that's the reason. So that level of attention to detail is what we need to bring from magic into programming, all right? Because I don't know where I was going with that. But yeah, we have to say that if there's a loop, there has got to be zero chance that it can be a truly infinite loop, because an algorithm, by definition, right? This is a definition of an algorithm, a classical definition of an algorithm. I don't know if it's really, people hold on to it even now, is that an algorithm, one of the first conditions for something to be called an algorithm, not just a procedure, an algorithm, is that it has to terminate, okay? Has to terminate. It doesn't have to terminate today, doesn't have to terminate next year, okay? In fact, it does not have to terminate in 100 billion years either, okay? I can write an algorithm that'll complete its job in 500 billion years, right? Because just before the universe itself is going to collapse into a black hole, the algorithm terminates, okay? It is still an algorithm because it is proven to terminate. Given an inordinately large amount of time, it is going to terminate. So it's an algorithm. It's a slow, inefficient, really bad algorithm, but it's still an algorithm. So in order to have that label, an appellation, that you're an algorithm, you just need to prove that you will terminate no matter what. That's 100% certainty. Yeah, that's what the magician told me, right? So so when we did this while true loop, how can we be sure that it will never be an infinite loop? Okay, so someone tell me that, because this is just practice in being a real, true professional programmer. Okay, there's a very small fragment of a program here. Hannah wrote it, and she wrote it in a way that was very clear that it was going to terminate. Okay, there is no way it's not going to terminate. So we know that it's going to be enough. We made some changes now. We made some changes and said, this is an infinite loop now. We don't have this condition and things like that, right? Well, strictly speaking, it is exactly the same as what Hannah wrote. But we just have to say, how can we be sure that this is guaranteed to terminate, right? There is no way that this can get stuck in an infinite loop. Most important thing, you have to keep in mind, every single moment you're programming, this is the first thing in your mind. Everything else, efficiency, correctness, all these things will come later. Proof of termination is like super duper important, right? There should be nothing out there that can cause your program to not terminate. Can someone tell me how you can be sure, right? This is a mathematical proof. This is why mathematics is so closely aligned to computer science. It's basically a mathematical proof. How can you logically prove that this algorithm, this fragment, code fragment, is guaranteed to terminate, okay? Is guaranteed to come out of there, right? How can we say that it is guaranteed to come out of there? Take a guess, okay? Take a guess. You're going to say, well, and it doesn't have to be, a mathematical formal proof. You can just say in English, right? Oh, I know it's going to terminate because of, so and so, right? And if you don't want to, I'll tell you how we reason that. It's basically just reasoning, thinking aloud and reasoning aloud, right? So I'll do that, and then you can also see. Correct me, right? You'll have a chance to correct me and say, hey, your reasoning was incorrect. Here's a case where it will not terminate. Okay, so we want to make sure that doesn't happen. Can someone tell me that? This is all practice for CS2A, also later programming. Okay, so take a guess. Take a guess why this is guaranteed to terminate. There is no case, there is no situation where it cannot terminate. That's what we want to say. Someone take a stab at it. Okay, all right, right. So here, so if it enters that if statement, it is guaranteed to terminate. Yes or no? Now, everybody should be on the same page, same step as me. Okay, otherwise this is not going to work. That's the reason being, I want everyone to be convinced that this, this proof, this very simple proof, it's a very simple mathematical proof. You've done lots of proof in mathematics, right? In math, you're doing proofs all the time. It's a very simple proof. So it's just a simple proof, and you need to be totally on top of this, okay? So the only reason, if it enters the if statement, it is guaranteed to get out of that loop, yes or no? Oh, actually, wait a sec. It's greater than. No. What I said was wrong. Okay, it is guaranteed to get out of the loop only if D1 is greater than D2. Yes or no? Yeah, if D1 is greater than D2, it's guaranteed to get out of the loop. Yes or no? Right? At least you have to tell me yes or no, or give me some corroboration that you're listening, right? Or my microphone is working. If at any point in the loop, D1 happens to be greater than D2, the loop will end because it'll enter the if statement. And there, D1 is greater than D2.
Yes.
And thank you. All right.
Right.
Okay, good.
Yeah, it's the true.
Right. So now what are D1 and D2? D1 is the player one's position. Yes. And we started off with player one on the left, which means he's at a low index. Player two is at a high index. And what do? Inside of the loop? We and we know that player speed is also non-negative, right? It's not zero, it's non-negative. It's a positive number. Yes or no? All right, great. So these are facts, right? Just like in math, we have these facts, and then we're going to use these facts and prove something. That's all. Okay. So all right. So we have a positive number, and we have two things here. One is low index, one is a high index. What are we doing in the loop, right? Either the if statement catches and it terminates right there. If it doesn't terminate, it goes to the next statement, where what we do there is take the left player and move that player to the right. The high index increases. Yes, it has to increase. There's no other way. 100% of the time, if you add a positive quantity to an index, then the index is going to increase. Yes. It's double, right? It's not an integer, so it's no truncation and all. It's a double, isn't it? Are you using by the way, player one pos? Are they doubles? Yeah, they're doubles. Okay, I just see half of that statement on line 84, right? It is a double. Okay, so it is guaranteed. Player P1 pos is guaranteed to be more at each iteration, right? P2 pos is guaranteed to be less in each iteration. Yes. So as the iterations progress, P1 pos and P2 pos, they're not going to stay stationary because we're adding and subtracting a non-zero number. Okay, so they're going to be moving towards each other, which means P1 pos is getting bigger and bigger. P2 pos is getting smaller and smaller. Yes or no? Yeah, just someone should,
Yes.
give me feedback. Yes. Okay. Thank you. All right. Hi. Now, our D1 is basically just the D1 is the difference between the player one position and, in fact, you know what? Yeah. All right. So we'll play minus star pauses. Okay. We can fiddle with that later. Okay. If necessary. Right. So at some point, P1 pos is going to be greater than P2 pos. Yes. Yes or no? At some point. And is that guaranteed or not? The thing that I'm always asking, right, as any professor is asking, is not whether it's going to work or not. Is it guaranteed or not? That's what, in mathematics, right? Is it guaranteed or not? That's the only thing you need to be focused on. Is it guaranteed that at every iteration, right, P1 pos is going to be bigger, P2 pos is going to be smaller, which means that if you keep on doing that, after an infinite number of years, even maybe, I don't know, not infinite, okay? So some point in time, they're going to cross over, which means P1 pos will be greater than P2 pos. Yes or no?
Yes.
Guaranteed? And it's guaranteed. Yes, 100% sure. Which means that at that point, it will get into the if statement. Yes, because P1 minus P2 pos will be greater than this. Basically, D1 minus D2 is going to be greater than 0. Yeah.
Yes.
Okay.
I don't
Oh,
exactly.
no, after spending so much time describing it, I actually realized that maybe that was insufficient for we're just going to the star because it's
Yeah.
possible that we're just going to the star. We're not asking for the crossover point and find out who
Yeah, I
the-
had that in to figure out like what to print out, like who won. So like since we're not doing that logic in this function, I think we can just return d1 minus d2.
yeah,
Right?
we can just do the return d1 minus d2. So no, wait a sec. I'm sorry, Hannah, you're saying we are returning d1 minus d2 right there on 90.
Yeah, but there's another like the d1 like there's also the case where d1 is equal to d2. Like because that would be
Hey, but you have less than or equal to. You have less than or equal to. That should catch it. Right? D1 will be equal to D2 only if they're both on the star. Yes?
wait, sorry. d1 will be equal to
D1 is equal to D2 if they're both sitting on the star.
yeah.
Right? So that is a situation when they're both equal. Until they meet, this is less than that. So it's never going to get into the if statement. Oh, I see. Yeah, we can change the position. We can change line 89. Change it line 89. On line 89, we can say if player as long as player 1 position is less than player 2 position. We don't have to even compare with the star now anymore. We can just keep going. Oh, I see. Because then no, that don't do that because it's possible that player 2 is moving very slowly, but this guy has gotten to the star. So what we really need to compare is the distance between the player and the star. That's all, right? So the distance between the player and no.
I think I was talking about line 92. I don't think we need that.
Oh, yes. We don't need that. Yeah. All right. So let's do that too, but that's still not done. Okay. So and then unindented. Right. So all right. So player one pause is greater than. Oh, yeah. I think that is good. I don't know why I was thinking so long about this. Okay. All right. So yeah, hopefully, when you're coding, Hannah probably didn't think this long about this and got right. So all right, so we got the player, and also it doesn't need to be indented 8 now. It can just be indented 4 spaces. So you can remove one level of indentation there. We can remove one level of indentation. Yeah, I know. Oh, even for the. In fact, we can do something better. Yeah, just remove the 4 spaces between int d1 and int d2 also, because they're all in there. Okay, all right. So if player 1 has crossed or reached the star or crossed it, or they've either way, then the race is finished. Okay, let's put a comment above that if statement on line 88. Hit enter on line 88. Yeah, and then indent and start a comment. Above the if. No, above the if. One more indentation. Yeah. The race is finished. The race ends when either player has crossed the star, right? Crossed the star. It's actually touched or crossed the star, but it doesn't matter, right? So for now, right, cross the star. All right, or reach the star. Let's say reach the star.
Also, should we make it a double instead of an int? D1 and D2.
Oh, I see. Yeah, let's make them doubles. Thank you, Hannah. Very good. Okay. I think D1 and D2 should be doubles. Just call them, make them doubles. Oh, but by the way, but pause. The position is not double. Position is not double, is it? Position is not double, is it? Oh, they are. Okay, positions are good. So position is double, and if they've crossed over, all right, good. D1, D2. We may have to check for some corner cases later, but we'll do that later. Okay. All right. So great. I think that, and then we adjust the speeds. No, the positions, and then set pixel positions, and yeah, that looks okay to me so far now. this ends when either a player has reached a star. Do we want to play it now? I think it's good. It's ready to play now, isn't it? Right. After we play it once, we can go back and change that, penalty, docking points and so on, and then we can have another go. Right. So you can increase the size of the console now, and then we can give it a whirl, and then. Oh, retry. Yeah, make that return 0 at the end because it doesn't. No, not there. Oh, sure. Yeah, there you go. And also at the end, you need to return 0 because the compiler doesn't know that at the end after. No, not there. Up. That other function. Outside the while loop. Yeah, there you go. Hit enter there, and say you can say return 0, and put a blank line above return 0 also. Just to be clear, right? So, and the reason we do that is because although using our logic, the humans can figure out that there is no way this while loop can exit like that. It has to exit in the middle because, right? But the compiler can't tell unless it does some sophisticated logic inside of the silicon. So that's why we say, well, compiler, this last return 0 is never going to be reached, but we still have it there to stop the compiler from complaining. Okay. So in fact, what you can do is put a comment on line 109, right? So on line 109, put a comment saying, you have to stop the code and then put a comment saying, also, that comment up right at the top saying class code 4 that we need to change. We can change it later. Right? So that comment should say not reached. Say not reached, full stop. Just to stop the compiler, not reached, and then a period, right? But stops the compiler, stops compiler from complaining. Complaining. Okay. All right. So if you run it now, I think it'll. Right. So now increase the size of the console. Yeah. All right. Now let's see. All right, Sabrina. Now, let's say Sabrina 2. No, let's say you're going to play Sabrina. No. All right. Okay. All right. Now. All right. Now type AL. Lots of ALs and hit enter. La. Oh, why did you do that? You lost a lot of, time. Your speed is going to player 1. Your speed is going to be very low now because of the
I
backspace
realized
and
I
all.
was typing number 1.
I see. But it wouldn't have mattered. By the way, it wouldn't have mattered because in the current version of HANA's game doesn't check for A and L.
Oh.
Yeah. All right. Hit enter and start the second player now. Go on, right? Because we don't have that warning now. We usually go. All right, hit enter. Oh, how come nothing's happening? Why is it not showing us the race? All right, now there's something going on here, something weird. So let's Control C out of this and then go back to our code and try and debug it. No, you got to, stop it. Right. So why did it not show the print 1D screen, track, clear, set pixel at, and at the respective positions?
I think it's because we're setting the pixels and then we're clearing it.
I'm sorry?
We're setting the pixels and we're setting like the star and then we're clearing it. Like right after.
Right
We're
before
setting
the
the
print,
stop.
right?
Oh, I see. The clear. Oh, I see. It clears a track. Oh, I see. So yeah. Take that clear screen and put it above the delete that. Like cut. Right now, put it above that set pixel at line. Set pixel at. Yeah, there you go. One more. Yeah, one more up, and then you can paste it there, and there you go. Oh yeah, thank you, Hannah. Who said that, by the way? Was it Hannah or Sabrina?
It was Hannah.
Someone. Hannah. Yeah, thank you, Hannah. Right. So I was under the impression that the screen that you see is separate from the screen that you maintain, the backing screen. It's but this is correct. Okay. I think if you run it now, Now this time, Sabrina, be careful not to hit backspace and all. Hit lots of ALs and then play against Hana this time. Okay, so your second player is going to be Hana. Right, so you're going to be typing you're going to be typing AL for Hana now. Yeah, you can hit enter now. All right, let's see what happens. Okay, all right, great. So it's suddenly they're it's waking and they're moving, and it looks like Hana's winning. Is it? Does it look like Hana's winning? I think she's closer. Yeah, Hana's closer. Hana's winning. Okay, all right, great, excellent. All right, is it? Yeah, she's definitely closer. And then, oh, we forgot to put the statements at the in main saying winner is Hana, because we have the names of the players and all, right? So we can do that. And we can also increase the speed a bit, maybe, I don't know. Oh, what you can do is you can use, well, we'll see if the termination condition works. Oh, something is wrong. Oh, it's waiting until it crossed over. Why did it wait until it crossed over? It should have said the race ended as soon as 2 touched the star. Okay, so let's go back, debug it. Let's debug it and see why is it not why is it wait, no, I think it's in show race. It's in show race. Why is it waiting? Because if player 1 pass is greater than or equal to or player 2 pass is less than or equal to, it should immediately break and say they've won. So why did it not do that there? Why? So you understand what I'm saying? Yeah, so it should not have let 2 cross over beyond the star. As soon as it should have gone into the if statement. Why didn't it do that? Why didn't it do that? Well, I shouldn't be the only one thinking, okay? So please, everybody should think, and like Hana was doing before, right? Trying to figure out why it didn't cross, why it let the 2 cross over. It shouldn't have let the 2 cross over. It did one, even one space, it shouldn't have crossed over, yes? All right, how about this? Just before you enter the while loop on line 86, hit enter on line 86. No, at the end of line 86.
Is it because we're updating the position after the if statement?
Sorry, Namrata, what were you saying?
Is it because we're updating the positions after the if statement?
Oh, yeah. Maybe that's what it is, right? I think what. No. That doesn't. Even though we updated, we didn't paint them on screen. We painted them, and then. How about we do this? Okay, just one, right? So cut the lines from 90 to 95. Cut the lines from 90 to 95. 90 to 95. Cut. Yeah, cut it. Yeah. Now and get rid of the blank lines. 2 blank lines also. Get rid of the 2 blank lines. Now put that after the print 1D screen. Put that after the print 1D screen. Yeah. Right. Even then, that I don't think is that's not. Well, that was just a small cosmetic change. Okay, I don't think that would have changed the logic in any way. In any, we get the positions, and then we set the pixels. We print the screen, and then we check to say who won. Or player 2 pass greater than or equal to, then it would have returned immediately. Try try again this time. You know, it's like Einstein said, you know, if something doesn't work, you just keep trying again and again, hoping that it'll work. It's not a good idea, right? Because we didn't change anything substantial in the logic, but I'm saying let's run it again to see if it'll work. You should never do that in questing, okay? Questing, people submit something, don't get trophies, submit the same thing again to see if I get trophies, no? Right? But why? I'm just trying to see, I'm trying to remember why it didn't. I want to see a replay of what happened there. One pause. Is it because they're doubles, right? If it's doubles, player 2 pause. Even then, it'll be less than star pause, so that should be okay. Track star pause and then. Run it again. I don't see any reason why it shouldn't. It should have crossed. Yeah, run again, and then this time, when you run it, you don't have to enter so many ALs. Just 4 or 5. Bam, 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 bam. Enter. Bam, 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 bam. Enter. Right. Okay. Well, see. I want to see if it actually crosses over. It shouldn't really cross over, because when it is actually on top of the star, that if statement should have been entered, because the position would be less than or equal to. Oh, unless. Okay, I think I know why. Okay, I think I know why. It goes all the way back to data representation. It's because we're using these doubles for the position, right? We're using doubles. So let's say the star is at index 40, okay? And then player 2 position may be 40.0 because it's a double. No, 40.5, right? So that still means that 40.5 is going to be on top of the star, but it's greater than the star position. So it's not going to get into the if statement. So we can fix that. I think we can fix this by just typecasting them to integers instead of doubles. Further. Yeah. All right. So I shouldn't have. Yeah. All right. So what we'll do is where's that if statement that breaks out of the loop? Yeah. Player 1 pause. What we'll do is just before player 1 pause, just say int player 1 pause, int within parentheses, on line 99, say int within parentheses of its own, int within parentheses of its own. Yeah, thank you. On the other one too. Right, I think that should fix it. If you run it now, I think that should fix it, because it'll take care of the case where 40.5 is actually equal to 40. No, I think this time it should basically just stop at the star. It shouldn't cross over and go to the other side. And while this is happening, because it's because Hannah and Sabrina are moving so slowly, one of you can look up our past code. I think someone used clock instead of sleep, to sleep for less than 1 second. Was that right? Did someone sleep for less than 1 second in using clock? Was it using clock or using micro sleep or something like that? No? Nano sleep, micro sleep. All right, so let's go to Google. Well, after this, we'll watch this happen. Oh, this time it looks like they're both equal, and it maybe it. No, maybe it's Sabrina's faster this time. Yeah, Sabrina's faster. Right. So that means one might cross over to the other side, but it shouldn't this time because we're doing integers. So. Yay! Okay, all right, good. So that fixed it. Now, one thing is, all right, let's put some finishing touches on this now. So let's go back to the code. And then in our main, let's go back to the code. Let's go to our main now. Let's go to our main. Yeah, further down in main. After show race returns, when show further down. Show race happening. Right there, you want to say on line 145, you want to say int result equals show race happening. No, int result equals show race happening. No, cut the previous line. Cut the previous line and put it there. Or you can say int result equals on the previous line itself. No. Get rid of that. Get rid of show raise happening. The words show raise happening, and then paste what you had before. There you go. Get rid of the blank spaces. Right now, now on the next line after that, yeah, get rid of the semicolon. Right on the next line, you want to say if result greater than 0. You can say winner equals player one name.
If result.
In fact,
what?
you want to use the ternary operator here? Well, you practice using ternary operator. Okay, so get rid of that. Get rid of that. And get rid of that. Unless you want to use an if, right? Hands up, those of you who want to use an if statement. Hands up. Those of you who want to use a ternary operator, left hand up. All right. I don't know. I can't tell left and right in the Zoom. Okay. Raise your hand if you want to use an if instead of a ternary. Okay. Only Mohammed. Who wants to use a ternary operator instead of if? Raise your hand. 2, 3. Okay. Right, we have 4. All right. Four people. Okay, Mohammed, you're out of luck. Okay. So we're going to use a ternary operator here. So hit on line 146. Indent in. It says see out. You can say congratulations, space, outside of the quote now. Now we're going to put the ternary operator inside parentheses, okay? Meaning that it is, it's going to be evaluated on its own. So open parentheses right there. Right, and now space, and inside you're going to say result greater than 0 question mark. Oh, here we have 3 cases, right? Oh, we can use a switch statement. Okay, now let's use a switch statement. Okay, because we have 3 cases. We have a chance to use all of these now, because especially since switch is going to be in your midterm exam and all. Okay, switch. Okay, so that's great. So get rid of that line. And say get rid of the line and say a switch result. Okay, switch result, right? And say switch result there instead. Switch result. Switch, and then result should be within parentheses. Yeah, and then outside of the parentheses, space, and then a curly brace. Oh, gee, okay, I'm so sorry. We cannot use a switch. Bummer. I was really hoping we can use a switch. The reason we can't use a switch is because we're not getting 3 discrete values, -1, 0, and +1, right? We're actually getting some negative number, any negative number, any positive number, and then those are the 3 cases we're getting. So unfortunately, I'm so sorry. I was looking forward to using a switch statement here, but hopefully you guys can come up with situations where you can use a switch statement in this code and post a version on Reddit. Okay, somewhere else, maybe not here. We have to use if. Okay, going all the way back to if. Yeah, Mohammed, finally you got your wish. Okay, so let's go back to the beginning of that line and say if result greater than 0. So go to the beginning of that line, 146. We got to redo this. Okay, so, yeah. And say if result greater than 0, right? If result greater than 0. Oh, you say less than 0, doesn't it? Right? So yeah, close, and you can and then hit enter, and then tab in. Now and then now you say player 1, right? If result greater than 0, player 1. I think player 1. Congratulations, player 1, and then left shift, player 1 name. Thank you, player 1 name. Left shift, and then within quotes, left shift within quotes, you say full stop, period, full stops, period, space, period, space. You can say you won the race, you won this race, right? And then period again, and then endl at the end. All right, now enter. Now back unindent one time, right? No, not all the way. No. Else if result greater than 0. Else space if result greater than 0. Greater than 0.
Shouldn't it be less?
Less than. Yes, less than. Yeah. And you can triple click and copy and change player 1 to player 2. No, you didn't triple click when you pasted. That's why you got the indentation messed up. right? All right. And then you need a final else too, because it could be neither greater than, neither less than. It could be 0. Yes. So now you can say else on the next line. You can say, see out. This race was a tie. Yeah. Okay. All right. So now we've done that and enter. So the return is still separated out. So one more thing that I wanted to do. Is it raise? I think. Well, yeah, we'll do one more thing. Okay. Just go to open another tab. Open another tab in your browser. Another tab in your browser and say how to do. How to sleep for less than 1 second in C++. How to sleep for, I think it's called nano sleep or micro sleep. We'll find out. Yeah, sleep for milliseconds. Yeah, click that one. I think it's millisleep or nano sleep. Maybe it's nano sleep. Further down. Let's look at a code example. They probably have a code example somewhere. Yeah, there you go. The first one. Sleep for. Huh. Okay, let's try this. Okay, let's try this. Now triple click that line. No, in there. Copy that, and then you see there's two other include files we need to put right at the top. Go right to the top, and under string under Unix std, right? Under Unix std, hit enter. Now you say hash include. I think it's called chrono. CHRONO. And then the other one was thread, okay? And then on the next line, hash include thread.
What was it?
Thread. THREAD. Right? Now go to the place where you had the sleep. Where's the sleep in there? I think it's in show race or something. There you go. Now go to the line above that, hit enter, and paste what you had. Yeah, hit enter and paste what you had. Right now, thread sleep for milliseconds. Right. So instead of milliseconds X, let's say we want to sleep only for 500 milliseconds. Let's say we want to only sleep for 500 milliseconds is half a second, isn't it? Yeah, I think it's half a second. 500 milliseconds is 500 is 1,000. Yeah, of course. 500 milliseconds. Now the players will start moving a little faster. Okay, it won't be like a tortoise race. It'll be more like a hare race. Okay, they're hare race. Okay, so all right, let's run it. Let's run it this time, and then yeah, let's try Erica and Mohammed racing each other this time. All right, okay. Yeah. Hey, you got the K instead of a C. That's great. Okay, because I usually make that mistake.
I was debating which letter.
Yeah.
Yeah, you got it right.
Oh, so it's still, is it too slow or is it? No, 500 milliseconds. That looks like it's slower than before, right? This looks like it's slower than before. I thought it was 500 milliseconds. Oh, you still have
Was
the
this
sleep one.
thread?
Yeah, get
Because
rid of
it's-
the sleep one. Get rid of the sleep one. No, then triple click that line and delete it. And then get rid of the blank lines also. Yeah. All right. Now I think it'll be faster. Okay. Now it'll be faster. Oh, now you got the C instead of K. All right. Okay. Yeah, okay, they're faster now. Okay, that's good. Now, in fact, what you can do is change the 500 to 100. It'll be a whole lot faster. Change that 500 to 100. It'll be a whole lot faster. It'll look like a real race too. Right. There you go. All right, so it looks much better now because it looks like a real race. Oh, Erica, right. You know, we can have the horse races. Oh, Erica is getting closer. I don't know. I haven't. That's how it's. The commentaries come on. I haven't actually seen one, but. All right, now, yeah, that's great. Congratulations, Mohammed. You won the race. Later on, you can make it nicer by putting stars above the congratulations line and things like that, and nicer. Now, there's one more thing I wanted to do. yeah. We want to penalize players for doing wrong things in calculate what do we call it? Get player speed. Yeah, let's go to the place where you get player speed. Where you say dock player for things and all. Okay. Yeah, there you go. Right. So here's what we're going to do. Now, by the way, let me do a check here first. This program is like 160 lines now. It's not like a short program. It's right. And it seems like it's long. It has lots of comments and code. I want to make sure that everybody's okay with this, okay? Because it's not like, because I think I know, so someone in my 2B class also said, I'm doing this other 2B in some other college, and we're not writing these big programs, and are we supposed to and all? So what I told them was, what I teach is what the government of California wants professors to teach students, okay? This is what the state descriptor says we got to teach. But however, we can be hard and fast about these rules. So different professors teach to different levels of the state requirement. So maybe other professors don't teach this here. Maybe they'll teach it elsewhere, or maybe the speed picks up, right? It's possible, right? Some professors will prefer to go slowly first and then suddenly pick up the speed when everybody's solid. So different styles. So I want to make sure that everybody's on the same page before we move ahead. Is this code okay? Is it comfortable, right? Are you guys comfortable with this level of coding? It's this is not, yeah, right. So I want to make sure that is everybody comfortable with this level of code? Meaning that if someone gave you this code, suddenly, and said, read this code and tell me what it does. You don't have to debug it in detail, but you should be able to read the code and say, well, I know what it does. Yeah, raise your hand if you're comfortable with that, and you're comfortable with this code, and you're able to, basically do something like this on your own. Please raise your hand, because otherwise that's my signal to say, can we do more things? Can we do more things? Yes or no? Mohammed, are you raising your hand, or are you just raising your hand? Okay. So everybody okay? Everybody okay? You Yang? Yeah? No, maybe some ask questions, okay? Before what time is it now? We got time, okay? We got a half hour, and we only need to do a little bit of change, a little bit more changes to it to make sure that we have all these penalties, with also places where I say, right, I've done these 2 penalties, you guys can do more, right? So so there will be scope for you guys to make more changes also, but I want to make sure that who is uncertain, right? It doesn't mean that you're completely uncomfortable, but you're still iffy, saying, well, I need to look at it more before I can feel 100% comfortable with it, right? Raise your hand if you're in that camp. No? So can I assume that everybody is like totally comfortable with this code? Okay. And yeah, either way, I get no answers, yes or no. So everybody is like right in the middle. I don't know. Right. So I'm going to go ahead and make these changes. And if you have a problem with it, you got to tell me right now. Say, hey, don't keep going ahead. Let's figure this out first and then go. Okay. Yes. Okay. Right. So here's what we want to do. Let me try and see what we can do. All right. So what we want to do is dock the user speed for things like repeated characters and so on. Okay. All right. Great. So we got it. We calculated time went that player speed. Oh, I see. This calculates player at the speed of player. Okay. Right. So here's what I'm thinking we'll do. Okay. So, and you can correct me if you have a better strategy or if you have more ideas, that's all fine. We'll just do one idea here. Okay. So we have the string given by the user, AL, 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 right? Now, we know that the only 2 characters that are permitted are A and L. Yes? So if the player accidentally types another character, instead of AL, they typed SL or something like that. So there's a spurious character in there. Yes or no? In that string. So I'm saying that every time you hit a spurious character, you'll just multiply the speed by 0.9, which means, it's just scaled down. Okay. So that's one. Another thing you can do is you examine the string, and that all the characters have to be strictly alternating. It has to be AL, 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 or LA, LA, doesn't matter. They have to be strictly alternating. Therefore, that's another thing you can check. You can check from the beginning of the string, you can scan to say, that's my character, is the next character, not that one. All right. If it is the same as the previous one, that's a stutter. Then another 0.9 multiplication, right? So I keep doing that every time a character is not the same as a previous character, 0.9. His speed keeps getting down, right? So that way you can enforce that condition. So there's two conditions already we've talked about. One is spurious characters, 0.9 doc, right? And then not repeating characters, 0.9 doc. And then you can come up with more, right? I'm sure there's more illegal things that players could do, and you can do that too. So I'll do one of them. You can do the other one. How about that? Yeah. Okay. So which one would you like me to do? Would you like me to do the first one, which is just scanning the string to see if there's anything other than A and L, then 0.9? You want me to do that? Or do you want me to do, and you're going to do the other one, okay? So, or do you want me to do this one, which is scanning the string, making sure that every character is different from the previous one, right? If it is the same as the previous one, then 0.9, the factor kicks in. All right, so I'll do one of those, you do the other one, right? That'll take us to the end of class, and then we'll play a couple of games too, right? So how is that okay with you guys? Is that a good arrangement? Which one do you want me to do? So someone should voice, verbally tell me which one you want me to do, and that's what I will do. Okay. So do you want me to dock the speed for repeated characters or for spurious characters?
I think maybe the alternating one you can do.
Okay. So
People agree with me.
vote. No, that's okay. We have one vote from Erica saying I should do the alternating one. All right. Anybody else has any other opinions or suggestions? That's fine too, right? Eventually we'll go with the majority vote. Right now, Erica's vote is a majority, right? So I will, if it stands like this, I'll just do the alternating character thing. Otherwise, no other. Everybody okay? Well, you want me to do the alternating character one? Yu Yang, when you say RE, do you mean regular expression? Yeah. Obviously, yes, you can, but you want to bring regular expressions. By the way, they are a construct. When you on a machine on a computer, you say ls star. If you done this, star is all files, right? So regular expressions are just a generalization, a formal generalization of this wildcard character. Saying, it's a pattern that will match many things. So what Yu Yang was asking me in chat, by the way, you should not ask in chat, you should just feel free to ask, is can you do these things just using regular expressions? Yes, obviously you can do them, but regular expressions are capable of much more than just this. And therefore it's heavy duty machinery. Because when you use a regular expression, what has to happen is that the regular expression is taken, it's compiled into what is called a finite state machine. I can teach you about finite state machines later on, 2B, maybe 2C, right? In 2C, I can teach you how to build a finite state machine of your own, right? It's very easy. That's what a regular expression is. And it does that, and it compiles it, and then it checks. It's really fast once it's compiled, but compiling it is all heavy duty, and it's not worth the time. That's why we're doing it simply. Yes? Yeah? Great. Okay, all right. So here's what we're going to do. We'll do that alternating character one. Okay, so now on line 62, hit enter. Line 62, hit enter. Yeah, now we'll say, let's start a comment there. Put a comment saying, scan the string for repeating characters. Scan the string for repeating characters, and scale down the speed for if they exist. Yeah, scale down the speed if they exist. No, yeah, all right. That's much better. What Sabrina started typing was much better. All right, so here's what we'll do. And also on line 62, hit enter. On line 62, hit enter, because that needs to be done first, right? And line 62, hit enter, right? And then start a to-do there, right? Start a comment, and then say to do, and say check the string for non-disallowed characters. Check the string for disallowed characters. This has to happen first, okay? Because then that's why the repeating characters will work later. All right, so And within parentheses, you can say anything other than A and L. Within parentheses, anything other than A and L. Yeah, right. So and now I hit an enter after that, so that it's a to do for you, clearly set out. Now we'll do the second part. Okay, so now we'll do after line 65, hit enter on line 65, and then we'll go to the next line. And so here's what we're going to do, right? So we'll say yeah, all right. So let's say char space a previous character. So we'll say prev underscore char, prev underscore char, prev underscore char, prev v underscore char equals where do we have the user input? Do we have the user input anywhere? Where do we have the user input, by the way? Where do we have that string that we're using to measure the
I think at the top in get player speed.
no, there is. I see it right there. Okay, string user input. Okay, all right. So we just need user input. Okay, so let's go back to that where we started typing. Pre-char equals user input square bracket 0. User input square bracket 0. And it is safe. Remember, okay? And again, every time I'm saying these things, right, equals 0, we do this, indexing into an array without making checks. In my mind, already, I know that it's a safe operation because we know that it exists. Because we know that if the user input length is 0, we would have exited the method before, right? On line 56, 55, 56, we do that check. So we know for sure that user input is not empty. That is why we're checking to say that, get me the first character. I know it's not empty, get me the first character. If you don't know it's empty, you cannot get the first character. Your program will crash. So these things have to be, subconscious decisions. The more practice you have, the more of these will become subconscious. That is the reason, okay? So, and again, I said, you got to type for loops while, the syntax needs to be in your head. That's not the only reason for practice, okay? These things like that, subconscious things that could potentially break your program. Those are things that will also need to be ingrained by practice, right? Things that you can figure out. You can read the program later and say, oh, you know what? Oh, yeah, I do this, but I forgot to check for an empty string here. So let me put it there. So you'll do that. Obviously, you'll do that. Every programmer does that during the initial stages, but they have to do that many, many times because it is practice that will automatically make that ingrained in their head so that when they're going to do that, if square bracket 0, automatically they know, oh, yeah, okay. They do that, right? So all of that is just practice, and that's why you have to keep doing. Right, on the next line, start a for loop. Yeah, on the next line. So you say for size t I equals 0, I less than user input dot length. Is this correct? Right, I plus plus. Length open close. Oh no, open close. Length is a method. Okay, length is a method. You got to say length open close. Okay, right. And then curly brace. We need two statements in there. So here you're going to say if. By the way, there is a small error here. Okay, and in fact, I equals 0 on the previous line should be I equals 1 because we've already taken the first character and stuck it in previous char. Right. So on the previous line in the for loop. In the for loop, right? On line 67. If you go to line 67, click on line 67. Yeah, I equals 0, change that to I equals 1. Yeah, because we've already taken 0 out there. All right. Now your if statement. If on line 68, you can say if user input square bracket I equals prev char. No, I square bracket I. Yeah, equals previous, yeah, prev char. On the next line, indent in, and you can say player speed times equals 0.9. I don't know. You can find the number. I'm taking 0.9. Maybe you'll say 0.5. you can figure that out by playing and experimenting. Okay. On the next line, back indent, go back. Right now you're going to say prev char is not the first character anymore. The previous char is going to be I, right? So it's going to be user input square bracket I. That's all. It's a very simple loop. All it does is that it'll assume the first character, it'll take the first character and it steps through all of the characters one at a time. And it checks if it is the same as a previous character, then it's, your speed has been reduced. And
Okay.
just keep going.
For
Yeah.
the speed, it's like it's supposed to be multiplied equals, right? So multiply to itself.
Oh, yes. Yeah, times equals. Did I say equals? No, I should have said times equals. Sorry. Thank you, Erica. Right? Otherwise, we would have seen the, race not work, and then we'd have to debug, right? I think that should be fine. Now, we can either play it, and then you can go and implement your to-do, or you can do the to-do and then play it too. Up to you. How about this? Okay, what time is it now? It's 9:40. How about I only give you 5 minutes? Okay, only 5 minutes. Alexa, set a timer for 5 minutes. Okay, 5 minutes.
Starting now.
Right? So yeah, go to line 64, and then you guys are going to flesh out that part. Okay, flesh out that part. You're going to do, dock the speed by whatever that factor. In fact, let's do one more thing. Okay, instead of 0.9, change the 0.9 into something called dock factor. Okay, dock factor or reduction factor. Call it reduction underscore factor. All uppercase, reduction underscore factor. Or penalty, right? Oh yeah, the reduction factor is fine. In fact, you know what? Rather than calling a reduction, call it penalty factor, right? Yeah. And then where you have, okay, on line 66, hit enter on line 66. All right, so you can say const double penalty factor equals 0.9. Oh, you're going to use this in your to-do also, right? So just triple click that line, triple click this line and cut it, triple click this line, cut it, right? And then go to the top where you have all the declarations. No, right to the top where you have all the declarations. No, not all the way, inside this function. Yeah, after string user input, right? Hit enter and paste it there. Now a blank line after that. And let's put a comment on that penalty factor line. Put a comment there that basically says speed will be reduced by this factor if the string is illegal. For illegalities in the string or something like that. For messed up strings or things. I don't know. You can figure with the words later. Fiddle with the words. All right, great. Okay, now not the whole 5 minutes. You only got 4 minutes now. You got to do that in 4 minutes. Okay, 4 minutes. You got to do that loop, whatever it is, to find out if it is, if these illegal characters are there. You're going to be docked again by 0.9 or penalty factor. Okay, once you do that, it's ready to go. Now after that, the class will be finished. But you guys can take that code that Sabrina will share, which is basically code that Hannah shared this morning. So Hannah worked on code. We took Hannah's code and then did more stuff to it in class. And then you're going to take that code and do more changes to it. And then when you post on Reddit, you can say, you can say something like, Karthik's version of Hannah's Star Racer game. Okay, actually, I like the game name Star Racer. Okay, Star Racer is kind of cool, right? So Karthik's version of Hannah's Star Racer, and you can post that code, right? Erica's version, Simon's version. You can and in each of your versions, you can add more bells and whistles. You can add, decoration around the, congratulations, or you can insert Erica's hack saying get set. Ready, go, right? Before you type AL. You can insert more penalties saying, well, we disallow right now spurious characters. We disallow repeated characters. Maybe you'll find more things to disallow, right? So you can do all those things. Okay? But go ahead, do it now. And you don't have to post it now because you got to do, hey, Sabrina, you don't have to post it now. And by the way, it's projects and stuff, not building blocks. Okay, it's projects and stuff. The flare is projects and stuff, but you don't have to post it now.
I'm going to forget.
I think it's called projects and stuff somewhere. Yeah, right. Don't post it now. after you've done the last part, okay? Do that last part.
Oh,
Yeah, do the to-do part, one of you.
okay.
You don't have to do it. Someone will call out the code and you'll type it in, okay? Someone other than Hannah or Erica, or Namrata also, right? Someone other than the three of them should call out the code, and you can type it in. And after that, we're ready to go. Go on, okay? How about you do it now? I think there's 3 minutes, okay? I'll put the hot water on and come back. Go on, okay? You gotta keep talking, or I can't even hear you.
We could probably use the
Um,
beginning of the same loop.
Yes, this one, right?
Yeah, yep. I don't think we care about the jar, but
I think
yeah, you can delete
Actually,
the jar
don't we-
thing. Mhm.
um
Anybody else want to add to it? Could do the if user input of I does not equal character A.
does not equal. Hang on. What is that
It's
one?
a space exclamation equals,
Yes, okay. Does not equal.
and then like a character A in single parentheses in single no, in like a single yeah.
This one should be I don't know.
I don't think we need that. Do we?
No, I think
I
we can
think
just,
we do because we have
yeah.
a for loop here.
or we could just make the I start at 0 and then you don't have to. Like the line 63.
Oh yeah.
And then one thing we could also do is like, since we know like it's supposed to start with like A, all like, if like the index is odd, right? Yeah, then it has to be A. Otherwise, if it has to be like L, so you can like maybe use like modulo for that.
Wait, sorry. If we're doing the repeated characters, shouldn't it be like a string of like AA? Oh no, I think. Can you guys hear me?
So wouldn't the index I plus 1 that is not equal to L? So would you put like a double and in the condition? The double and symbol.
Wait, sorry. I think my audio like cut out. Can we start over that last part?
So you add a double and in the condition. Is it
Uh-huh.
double, or is it double and, or I think you can just type and, right? A and D. After
Where?
the A, after the, yep.
Oh,
Yeah, sorry, I was just thinking about the like if they put in another letter and I was like, oh right, and it's the
Oh,
I didn't cover the stuttering part.
And then user input I plus 1.
this one.
And then does not equal L, right?
Yeah.
Well, actually, is it supposed to be? Is it supposed to be equal? Because you want to do something when it is repeated, right? You want to dock the points.
I don't know if my audio cut out and you guys didn't hear me, but shouldn't this be a string where it should look like this? Oh, so it catches like a stutter or something? I mean, not a stutter, a repeated? Or is that incorrect?
No, I don't think it can be a string because when you use the indexing thing, the square bracket, it I
Oh,
think
okay.
it outputs characters, right? Or it's gonna compare a character. It's not.
Yeah, it'll probably fail out.
And then I guess if like there's different ways to do it, but if we're doing it like this, then like you're checking like pairs, right? So then in the for it would have to be in the I plus plus, but like I like has to like go by twos, right? Because like you're checking if like each pair is like correct.
What does this chat say?
But I guess like that wouldn't work either if they're like if they like have like an odd number of characters they enter.
Well, this would be correct for the stutter, right? So shouldn't we, it would be like 2 if statements anyways? One for the repeated, one for the stutter. Okay, wait. Yu Wang said,
I think if we're doing this, like, not the stutter, but just the A and L, it's because I was just thinking about like, what if they put another letter, but like that's why they're not A.
This
But yeah, if we're
is-
doing A and L, then if user input equals A and the user input next letter isn't L, then
is
penalty.
or
right?
1 or 2? Is 2 of them, right?
Yeah.
Okay, hold on. I'm trying to copy what Yu Wang is saying. Am I getting this right, Yu Wang? Okay, I think I got it right. Okay, this is what Yu Wang typed in the chat.
For the last condition, would you have to do I plus like user input of I plus 1? Because if it's -1, would it give an error at the first time?
That's what I was thinking too. Like, input 5.
And then also like if you are doing I plus 1, then like you'd have to do like in the for like length -1, because then if you get like the very end, it's gonna go over.
Yeah, I see what you mean.
You guys good? All done?
He's
Like a
saying you can make an
minute.
edge case for the first and the last.
Why, what is it? I think you got it right.
We're just figuring out this last part because we have the 3 cases of if it's not A, it's not L, and if the user input equals the next one, the following one, but then it'll fail because
Oh,
there
I
won't
think,
be the
I
last
see.
one.
Basically skipping one character is what you're saying.
Yeah,
Is-
'cause-
yeah, I'll say, my suggestion is take it one step at a time. And just do it this way first, which is basically what you got there is almost right, right? So scanning through the characters, if any character is not an A and not an L, 0.9. That's all. If character is not an A and it's got to mean and, right? If it's neither an A nor an L. No, it's double ampersand. Yeah, but now then you can say player speed is times equals a penalty, and you can get rid of the next line. Yeah.
So it should be
now-
2 if statements, right?
No, that's it.
Oh,
See that
but-
that line, that if statement will fire if either it is not an A or not an L. Only A and L are allowed in that.
but doesn't that only what is it called? Do this condition, the other stutters, not the repeated characters?
Oh, the comment. Yeah, I see. So this part, this is the part that I did, I think. So get rid of that comment because that comment is not misplaced there. Get rid of the comment. Get rid of the comment.
The whole thing?
Oh, actually, things like dock the user for things like. Don't say things like. You're only doing one thing there. Dock the user for disallowed characters. That's all that is. Dock the user for disallowed characters. Excellent. I think that's it. You can get rid of the closing brace. You can get rid of the closing brace. In fact, you don't need the closing brace or the opening brace because the for only has one statement in it. The for statement only has that if statement in it. So you don't have multiple statements. So you don't need the brace. That's okay. You can have the brace, by the way. Right now, I'm going to show you before it's already the end of class. I'm going to show you one very nice thing. It's called De Morgan. Augustus De Morgan came up with a set of laws by which you can rewrite conditionals in ways that are easier. Okay, so I'm going to just put it in comments there. So go to line 62. Go to line 62 and hit enter. No, not 62. I'm sorry, 63 and hit enter. No, not there. Just before the if statement. Just before the if statement. Or in fact, you know what? After the if statement. After the if statement. Yeah, after the if statement. Hit enter. Yeah, there. Where do you have it? There you go. Now you can put braces in and all, right? For your for statement, put braces back in because we're going to do something there, right? Yeah, put braces in, and inside the brace, under the if statement. Yeah, under the if statement, hit enter there. Hit enter. Now we're going to say put a comment there inside indent in, and put a comment and say same as the previous if statement. Same as the previous if statement. Rewritten using De Morgan's laws, and then in parentheses you say look it up because it's in the midterm. Okay, De Morgan's laws are in the midterm. What is it? Not rewritten. What was I saying? Same as the previous statement. If statement. De Morgan's laws, right? Rewritten. REWRITTEN. Not you wrote return, rewritten. Using De Morgan's laws. Using D, capital D. I think it's lowercase de. Morgan. Yeah, Morgan's laws. Okay, and then within parentheses say look it up for midterm. Okay, on the next line, you can say if, and then open parentheses, vertical bar right there, vertical bar. No, not vertical bar, exclamation mark, not, if not, right? If not, and then now within parentheses, you're going to say if user input of I equals A. No. If not, if not, yeah, there you go. No. If vertical, if exclamation mark, now open parentheses. Now here, another open, yeah, there you go, right? User input square bracket I, and it's not going to be not equal to, it's going to be equal to, right? Equal to A, double equals, right? And then you're going to say or, 2 vertical bars, or, right? 2 vertical bars. No. That's after that. Yeah, and you got an extra space there and all inside after the before the parentheses. After A, you got an extra space, and you can say user input of I equals L, right? If user input of I, yeah, equals L on the next line. You can say player speed equals player speed star equals penalty factor. Now, so now you have that comment on line 66. Turn that into the start of a block comment, right? So make that, yeah, there you go. There you go. All right. Now go after the if statement, and then close off the block statement. Okay. All right. So this is exactly the same as before, just rewritten using De Morgan's laws. De Morgan's laws are really, really handy because it just says, you have a really complex conditional statement. People have, a programmer has to look at it and pore over it and think about it for like 10 seconds before they finally figured out what the condition is. Using De Morgan's laws, you can actually simplify things. Now, these are things that you will actually learn in discrete mathematics. I don't know how many of you are enrolled in discrete mathematics. There you go. All right. So if you're not enrolled in discrete mathematics and you're majoring in computer science, you have to enroll in it next class and next quarter. Okay. It is like super duper important and it's very, very useful, especially when you go to 2C and all, where you're going to be dealing with graph algorithms. Okay. Graph algorithms. How do you know if it's going to work or not? Is it going to, can you prove it is right? How can you do the proof? The proof uses lots of things that you learn in discrete mathematics. And it's beautiful. Okay. It's beautiful. And in fact, at Foothill, Patrick Morris teaches discrete mathematics, and I've heard very, very nice things about his class. Okay, so if you're going to do it at Foothill, so just enroll in Patrick's discrete math class. Okay, in fact, I remember a long time ago, Patrick and I had a conversation about some algorithm in 2C, some graph algorithm in 2C. And Patrick said, hey, yeah, that is the thing that I teach in discrete mathematics too, right? So it is like super duper useful. So this is De Morgan's laws, and doesn't make sense. Instead of saying, the first one says, if the character is not an A and not an L, it's wrong. The second one is saying, if it is not either an A or L, it is wrong. It's exactly the same, isn't it? They're exactly the same, yes?
Would the not
Not an A?
have to cover both?
Yeah, the exclamation's only on the first one.
Oh, yeah. I'm sorry. Yes, you're right. I can't see. Oh, yeah. So just get rid of the inner after the A thing. You get rid of that. Get rid of the closing parentheses there, and then get rid of the opening on the next one. Yeah, I think that should make Namrata happy. Yes. All right. Okay. Great. So that should work. Is everybody okay so far? Right? We actually covered De Morgan's laws, which we should have covered, the first week itself. Actually, it doesn't make sense in the first week, but certainly it'll help you in discrete mathematics. Okay, it's not just this one. There's 4 or 5 different statements like that, and they're all very useful rewrites. Okay, useful rewrites, because I know that sometimes I've seen conditionals that are this big, like 90 columns, 90 column wide conditionals I've seen in programs that some other programmers came in and said, that can be simplified using De Morgan's laws, and they got it down to like 20 columns. And you can right, you think of yourself in a professional programmer's shoes. Maybe you're already a professional in some other language, right? Think of the situation and look at a program. You got 90 lines of code here and 90 column lines of code, but here you only have 20 column lines of code. Okay, this is like a huge time saver compared to that one. As and when you get more and more experience with programming, these things like simple syntactical structures and so on will start becoming less important. What will become more important is what can save me time. Okay, that will start getting front stage. It'll get more and more important as you become more and more experienced in programming. you'll start looking subconsciously for everywhere you'll start looking, what can I do to make it faster for running, but also faster for me to code, because my mind is now working faster than the computer, right? So I got to do all these things. And so you start coming up with these things that will make it faster for yourself. De Morgan's laws are like hugely useful, right? Not just this, there's other constructs too, other programming patterns you'll use, right? And all of those will eventually come together and make you a star programmer, where you're basically just knocking it out, right? And just doing it at a speed that is probably incomprehensible to many other people that are not trained in programming. But for a trained programmer who's standing by you, they can just follow your code and say, hey, you know what, that was wrong, fix it up, change the regular expression there. And so all those things that will just come naturally, automatically, right? There's no need to go and learn these one at a time and say, oh, I need to do that. No, just keep practicing. And when practicing, you automatically learn lots of things which are not thrust at you, because you're learning them for yourself. You're not learning them because your professor told you to do, right? When you learn them for yourself, they become your self property, right? Your own property. When you learn them because I told you to, they're still my property. Oh, both of them are here. All right. Okay, so there you go. All right. So that was basically the end of class today. And you guys are more than welcome to hang around and talk more if you want. But otherwise, you can. No. All right. Otherwise, I will see you guys on Thursday. But on Thursday, we won't do any new topics. Okay. I think that's what I promised. Okay. And I think Foothill also does not encourage professors to teach new topics on the day of exam. So on Thursday, what we'll do is come prepared with lots and lots of questions regarding stuff that we've already done. Anything, right? Starting from data representation all the way up to here and say, hey, I'm still unclear about this, still unclear about that, okay? And if necessary, we'll take a vote and say, well, these are the topics we'll do first and so on. We can do more of that, okay? So we won't do anything new on Thursday. We'll cover this, but it's going to be important, okay? Because it's all the, stuff that's coming back to you in the midterm. Was that okay? Yeah? All right. Thank you all very much. Especially thank you for Hannah, right? Hannah for creating the first version of the game and sharing it and all. It was really cool. And then Sabrina, all right? You did fantastic. All right. So you were one step ahead of me most of the time, and that's the reason we managed to get the game completed and finished. And Karthik for sharing the original version of the code. So I think it all managed to come together, right? I kind of wrapped up, right? This game is kind of wrapped up now, and I think it's very nice. And in fact, if any of you are proficient with iPhone development or Android development in Java using an iOS app, easily turn this into a non-network connected standalone game, no ads, nothing. And instead of typing A and L, you can have two buttons on either side of two button icons. And say, tap those two buttons fast as you can. Bam, 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 bam. That's your player one, right? And after that, you give the iPad or your iPhone to your brother or sister or friend who's sitting right next to you, and they can go, right? And when they've done it, you can say, now play the race and hit the third button, and you'll see the thing happen, right? So all of those cool things you can do once you have the basic logic working, right? Because all these other things, anything you see, it's all exactly the same as this. What you see is really just the icing on top. You only see the tip of the iceberg. Google, Microsoft, any program, right? Even Fortnite and all these other massive programs, what you see is only the tip of the iceberg. It's just the icing that can be changed without changing the core logic. But the core logic is the strength of the program. That is what drives everything. So that can be there. And then, later on, Epic Games could decide, well, you know what, we're done with the, Fortnite look and feel. I want to bring in a medieval look and feel to it. So I'm going to bring in like, Game of Thrones like characters. And so completely different artists, graphic artists come in and they'll change everything, including even some interactions. But the core logic will still be the same. That's the hard part, okay? The rest of it is eye candy. Eye candy you can pay for, right? You can pay and get eye candy, but paying and getting intellectual effort is harder. It's not impossible, but you got to screen the person. You got to find out if they're intellectually solid and all, and then get them to write code. But eye candy is good because you can say, well, you know what? Do this. If it looks good, I'll pay you. If it doesn't look good, I won't pay you. Yeah. So that's important, but it has its place. And so this is the thing that you need to really get solid on, because that is where you have total control over how the game will behave. All right. Thank you all very much for sticking around, for your patience. and your understanding and working through this code. And I will see you on Thursday. Okay. Thank you. Bye.
Bye.